Civil engineering isn't just about concrete and steel anymore. The industry is transforming. Think smart cities, green materials, and infrastructure that adapts in real time. We're entering an era where our buildings and roads are intelligent, efficient, and sustainable. In this video, we'll break down the top civil engineering trends for 2025 and the skills you'll need to lead the way. Let's talk about BIM, Building Information Modeling. It's not just a 3D model, it's a data-rich digital version of your project. The real game changer is the digital twin, a live, virtual replica of a real-world asset. Sensors feed real-time data from the actual structure to its digital twin. If a truck crosses a bridge, the twin registers the load. Engineers can run simulations and test responses before events happen. In the UK, digital twins help manage smart highways and prevent traffic jams. This is predictive maintenance, fixing problems before they start. Welcome to the era of intelligent infrastructure. Now let's give our digital models a brain, artificial intelligence. AI analyzes massive project data, optimizing schedules and budgets in seconds. It predicts costs, runs thousands of what-if scenarios, and helps you plan for every contingency. Generative design lets AI create hundreds of efficient, innovative structures, often with shapes humans wouldn't imagine. Drones equipped with cameras scan sites, while AI spots cracks, corrosion, or safety issues instantly. AI is transforming safety, design, and project management. It's not just about automation, it's about creativity and foresight. With AI, civil engineers can build smarter, safer, and more efficiently than ever. The future project manager is part engineer, part data scientist. This is the new standard for building the world. Robotics and automation are reshaping construction sites. Autonomous excavators dig with millimeter precision 24/7, guided by digital models. Bricklaying robots work 3 times faster than humans, while skilled workers oversee quality and complex tasks. Robots now tie rebar, paint, and install drywall, taking on repetitive and hazardous jobs. Automated concrete printing is revolutionizing how we build. More on that soon. The result? Faster, safer, and more affordable construction. Human workers focus on oversight and problem-solving, while robots handle the heavy lifting. The construction site of 2025 is a high-tech, efficient factory. This is the new face of building. 3D printing is now building entire homes in under 24 hours. Giant printers lay down layers of special concrete or recycled materials, following digital blueprints. This is a game changer for disaster relief and affordable housing. Rapid, low-cost, and durable. 3D printing allows for creative, organic designs that traditional methods can't match. It reduces waste, cuts labor costs, and uses greener materials. The future is being printed, layer by layer. Concrete and steel built the modern world, but they're major carbon emitters. Now the industry is shifting to low-carbon materials like green cement made with industrial waste and recycled aggregates from demolished buildings. Alternatives like bamboo-reinforced concrete and mass timber are gaining ground, locking away carbon and reducing emissions. Life cycle assessment tools let engineers calculate a building's environmental impact before construction even begins. These tools are now integrated into BIM, helping designers make greener choices in real time. Sustainability is no longer optional, it's a core requirement. The materials we choose today shape the planet's future. Civil engineering is building with a conscience. Net zero infrastructure aims for zero emissions during construction and operation. It combines energy efficiency, passive design, and on-site renewables like solar panels. Buildings generate their own power, recycle water, and sometimes even feed energy back to the grid. This approach is scaling up to highways and entire city districts. The UK's National Highways is targeting net zero construction and maintenance using electric vehicles and green bridges. Net zero isn't just a buzzword, it's the new standard for responsible engineering. Infrastructure is becoming a positive force for the environment. The goal harmony between what we build and the world around us. Surveying has gone high-tech with drones and LiDAR. Drones map massive sites in minutes, creating detailed 3D models using photogrammetry. LiDAR sensors scan landscapes with lasers, delivering centimeter-level accuracy, even through vegetation. These tools track construction progress, spot errors early, and ensure quality control. Weekly drone flights compare as-built reality to digital plans, keeping projects on schedule. Surveying is now faster, safer, and more precise than ever. Engineers have a digital superpower at their fingertips. The age of flying robots and laser mapping is here. The Internet of Things is giving infrastructure a nervous system. Smart sensors embedded in bridges, tunnels, and pipelines monitor stress, vibration, and corrosion in real time. Data streams wirelessly to engineers, enabling predictive maintenance and instant alerts. Tokyo's subway and US smart bridges already use IoT to prevent failures and improve safety. AI analyzes sensor data, spotting subtle changes before they become problems. Infrastructure is now self-monitoring and self-reporting. We're building systems that protect themselves, and us. Smart infrastructure is safer, more resilient, and more efficient. The civil engineer of 2025 is a hybrid, part builder, part coder. Coding skills, even basic Python, let you automate tasks and unlock the full power of engineering software. Data analytics turns project data into insights for better designs and decisions. Mastering tools like Revit, Civil 3D, and Primavera is essential. The most successful engineers are lifelong learners, adapting to new tech. You'll bridge the gap between concrete and code. The future belongs to those who can speak both languages. Be ready to lead in a digital world. Construction is going virtual. Remote collaboration is the new normal. Cloud platforms let teams design, review, and inspect projects from anywhere. Remote site inspections use 360-degree cameras, saving time and catching issues early. VR and AR let teams walk through digital models, spot clashes, and make changes before building starts. On-site, Arkansas overlays digital plans onto real walls for precise installation. Cloud-based tools keep everyone working from the latest plans, reducing costly errors. The job site is now a connected digital ecosystem. Virtual construction is making projects faster, smarter, and more accessible. The world is entering a mega project boom. Trillions are being invested in infrastructure. From the US to India, the EU to the Middle East, nations are building smarter, greener, and more resilient systems. Demand for skilled, tech-savvy civil engineers is skyrocketing. Projects focus on climate resilience, smart mobility, and modernized water and energy systems. The emphasis is on sustainable, connected infrastructure. If you have the right skills, you'll have your pick of impactful projects worldwide. This is a golden era for civil engineers. The future is being built on a massive scale. The future isn't without challenges. Material costs are volatile and labor shortages persist. Global supply chain disruptions and geopolitical instability make project planning complex. Automation and robotics are essential not just for efficiency but to fill labor gaps. Risk management is now critical. Source materials flexibly, build resilient schedules, and use data analytics to predict disruptions. Great project managers are agile and proactive. Navigating these challenges separates the good from the great. The industry's future depends on adaptability. Success means building resilience into every project. New building codes and regulations are raising the bar for safety and sustainability. Stricter rules demand stronger, more resilient structures, especially in disaster-prone areas. Emissions limits and energy standards are now mandatory in many regions. Digital tools like BIM and lifecycle assessment help ensure compliance and document environmental impact. Technology is essential for navigating complex regulations. Engineers must stay current with evolving codes. Building responsibly is now a fundamental part of the job. The future is safer, greener, and more accountable. As infrastructure gets smarter, it becomes a target for cyber attacks. Hacked traffic lights or power grids could cause chaos or endanger lives. Civil engineers must now understand cybersecurity basics and work with experts from day one. Secure networks, encrypted communications, and backup controls are essential. Cybersecurity is as important as structural strength. Protecting digital infrastructure is a core responsibility. The future engineer builds for both physical and digital safety. Strong bridges are now strong in every sense. Civil engineering in 2025 is digital, sustainable, and full of opportunity. We're building intelligent systems that will shape society for generations. The challenges are big, but so are the tools at your disposal. Embrace technology, master BIM, learn to code, and stay curious about new materials and AI. The future is something we build, not just something we inherit. If you're ready to lead, now's the time to dive in. Subscribe for more insights into the future of engineering. Thanks for watching. Go build something amazing.